Hi, I'm Peter Shaw, ham radio call sign KF7EGZ. In this video, I'll show you how to upload frequencies to your ham radio with the CHIRP software and how to manage multiple radios. I'll see you inside. I'm a ham operator in the Seattle area and a member of the Seattle Auxiliary Communication Service, or ACS. This is a volunteer organization of hams and is part of the Seattle Office of Emergency Management. The group's purpose is to practice radio communications in case normal communication channels get disrupted. Stop by our Monday Night Net or regular meetings. Check the website for more information. ACS maintains a list of frequencies recommended for members to have on the radios. The list is in a standard format, or ICS 217A. Every so often this list gets updated, and so the radios also need a refresh. In this video, I'll show the process for programming one radio first, and then show a system that I use for managing multiple radio models. I'll break down this process into steps. Step 1 is to get a copy of your radio's memory onto your computer. Step 2 is to download the new frequencies from the ACS website. Step 3 is to upload the new frequencies to your radio. As a bonus step, I'll describe a system that I use for managing the information across multiple radios. Let's get started. The first step is to get a copy of your radio's memory onto your computer. I'm using the CHIRP software. I'll demonstrate these steps with one specific radio, a Baofeng. The process for other radios is pretty much the same. Here's my configuration with the radio connected to my computer with a programming cable. I'm using a Mac with virtual PC software. As you plug in the cable, you'll see the device appear. It's not a bad idea to check which serial port the device is using, COM3 in this case. Next, we'll start the CHIRP software and select Download from Radio. Be sure to specify the port and the radio details here from the extensive drop-downs. Each radio has different instructions at this point. Follow these exactly for best results. Once you press OK, you'll see activity on your radio and the cable, and the progress bar. Once it's finished, you'll see a listing of your radio's programming memory. Here we see the 128 channels of the Baofeng. Some of these are blank. While you have this data in front of you, it's not a bad idea to poke around to see what other settings you might want to customize. For example, the Baofeng has a couple of fields to display a message at power on. Here I have my name, Peter S., and my call sign to display at power on. Another setting lets you program an FM broadcast station to listen to. Since you'll be overwriting your radio's memory, you should save a copy of the current contents to a file on your hard drive so you can revert if needed. The default name for this backup file is the radio name and the date. The next step is to download the new frequencies from the ACS website. The website contains a number of files with the new frequencies in the ICS 217A format. As always, it's a good idea to take a look at the README file. There are a number of files here as described in the README. In this simple example, we'll work with the compact voice-only listing. Later in this video, we'll work with other formats. Here I've downloaded the voice compact file onto my hard drive. It has 143 memory channels which won't all fit onto the Baofeng, so the next step is customization. In this step, we'll customize the CHIRP data with the new frequencies and upload it to the radio. Starting with the file we just downloaded, I find it helpful to color code the channels. The first few I leave as is, but I have replaced the alphanumeric name of channel 1 as simply PSRG. Here I have simplex in violet and repeaters in yellow. The last group are the 6-meter frequencies that I won't be using on the Baofeng, so I'll simply delete these channels. Now there's 107 channels in this file, which will fit in the radio. From here, I'll export a CSV copy of this workbook to my hard drive. So now back in CHIRP, we'll be completely replacing these contents with the new data. So on the Memory tab, I'll select all the current channels and delete them. I'm left now with a completely empty list. But recall, all the other stuff is still there. This is why you actually need to start with a file obtained from your radio, not just a blank CHIRP session. Next, I'll import the CSV file that I just saved from Excel. There it is. CHIRP's import dialog gives you a fair amount of flexibility on how you want to import the new data. I just like to curate my data externally and then import it all at this stage. Once again, it's a good idea to save this copy of your radio data image. This is advice given from the School of Hard Knocks, as you can probably guess. So I'll give it a really long but descriptive name here. The only remaining step is to upload this new image to your radio. It's pretty much the same process as the download, but in reverse. And that's it. You've just programmed your radio. Lastly, I've developed a system that I use with multiple radios. I have 3 radios, each with their own characteristics. My Ace2 Mobile has a lot of channels. I use this for both voice and data modes like WinLink. The other two are handhelds, and I use these for voice only, and none of these has 6-meter capability. So back on the ACS site with the programming files, now I'll download both the full voice and the data files. The full voice has the same information as the compact voice, but the channel numbers line up better with the ACS, VHF, and UHF numbering system. Here I've got the full voice listing. You can see the channel numbers now contain skips. The other file contains the data frequencies. This new combined file now contains both of the original listings, but they've been concatenated. This file cannot be used as is because the location column no longer contains unique integers. This lower part repeats beginning at 1. Here I've created a master Excel file for all of my radios. This also cannot be used as is, but is used to generate CSV files for each radio. In this file shown, I've color-coded the channels as before. But I have now included extra columns, one for each type of radio. These new columns contain the planned channels for these radios. I've also renamed the original location column as L-Orig, so I won't get confused later. For example, the ICOM channel list just starts at 1 and goes to 68, but the ASU goes to 273. I've also excluded the 6-meter group and compacted the digital channels. Once I have this list developed, I can print up a number of copies and keep them with my radios. I don't have to have different versions of the channels floating around. I just have one list and multiple copies. I use this copy as a master reference and use it to generate files for the radios. For example, if I want to generate a file for the Baofeng, I'll start by copying everything here and creating a work area to prepare. In this new work area, I'll simply delete the channel columns for the other radios and also delete the original location channel, leaving the Baofeng column, and then I'll just rename this as location so it'll be recognized by CHIRP. Next, I'll look for rows that are missing the location entries and just delete these. And from here, all I need to do is export the data as a CSV file, making sure to carefully label it. In CHIRP, I have previously saved an image file for the Baofeng called blank. In this case, all the channels have been removed to make an easier starting point. It still has all the other data from my radio. Now I just import the new CSV file I just saved. After I do this, there are now gaps in the frequency list. These are just skipped over as you navigate the channels in channel mode on your radio. The reason I start with a blank channel list is to make sure the blank channels stay blank. If my starting file has data in these channels, the data will not be deleted, making for confusion. Again, the school of hard knocks. And that's it. I have a CHIRP file ready to upload, and I can easily generate similar CHIRP files for each of my other radios, and print out a single frequency reference for all of these. And there you have it. I'll see you on the air.